Hello, people of 2021. I'm from the year 1, and we have invented time travel. The key to time travel? The atom. Today, I will give you a tour and show you how your modern understanding of the atom came to be, so that one day you may have the chance to appreciate science. Let's go!
I am left with two smaller yet equal pieces of bread with the same properties. Thusly, it follows that if I were to split bread again and again and again and again, eventually I would be left with tiny millions of particles of invisible pieces of bread that could be divided no longer. The entire universe must be made of different shapes and sizes of these particles, all flying around and colliding with each other to form the matter that the universe is made up of. I shall call these indivisible particles atomos.
Atomos was actually Greek for indivisible, and thus the atom was born. On to our next destination.
If I take this mercury and this oxygen and I mix them, it creates mercuric oxide. But the mass of the new element is equal to the mass of the two starting elements. Thus, it follows that no mass was created or destroyed, and mass can only be changed or transferred.
With his ideas and experience, Lavoisier established the law of conservation of mass. This idea becomes even more important with our next scientist, John Dalton, and his atomic theory.
After years of studying pressure and the way gases combine, I have come to many different conclusions on the way that different elements form and mix together. Following my research, along with a theory posed by Democritus, I have created a new theory, the atomic theory.
The atomic theory is essential to our understanding of atoms and is as follows. 1. Matter is made up of atoms that are indivisible and indestructible. 2. All atoms of an element are identical. 3. Atoms of different elements have different weights and different chemical properties. 4. Atoms of different elements combine in simple whole numbers to form compounds. And 5. Atoms cannot be created or destroyed. When a compound decomposes, the atoms are recovered on chain. Some parts of these principles will be disproved later, although this is a great start to our understanding.
There's hydrogen, and helium, and lithium, beryllium, boron, carbon everywhere.
Shh! Let's not disturb the father of the periodic law. He's currently working on his new book, The Principles of Chemistry, and organizing all known elements into the periodic table by atomic mass. He noticed transformed as he organized the elements this way. This is essential to understand the correlation between atoms and matter.
I'm here in Cavendish Laboratories, and this is my cathode ray tube. Inside it, particles deflect away from the negatively charged plate towards the positive one, indicating that they themselves are negatively charged. Additionally, I discovered that the particles are smaller than a hydrogen atom, which is an atom, previously thought to be the smallest particle in existence. I propose that the atom itself is composed of negatively charged particles, which I shall call corpuscles, floating in a soup of diffuse positive charge, like a plum pudding.
Thankfully later, scientists changed the name of corpuscles to electrons. Still, the cathode ray experiment proved that atoms vary depending on small charged particles that make them up. The model Tomson developed, while being an important step in our discovery of the atom, was later corrected and revised by our next scientist, Rutherford.
When the alpha particles from this radium are fired onto this thin gold sheet, most of the particles pass through, indicating that the atom is largely composed of empty space. Some deflect off slightly, indicating a negative charge, meaning they are probably electrons. However, some deflect at great angles, which could only occur if there is a positive charge. It's as if you fired a 15-inch artillery shell at a piece of tissue paper and it bounced back at you.
With the gold foil experiment, Rutherford disproved Tomson's proposed structure of the atom, implying instead that the atom is composed of a nucleus holding all the positively charged particles and electrons orbiting in rings around the nucleus, like the planets around the sun. This also proved that the atom is composed of mostly empty space. While Rutherford was on the right track, many scientists were yet to improve on his ideas.
These radioactive decay chains certainly prove a lot about the atom. Some elements have different atomic masses but the same chemical properties, but different physical properties and radioactive properties. I think that different variations of the atom can be unstable nuclei.
Working with other scientists such as Rutherford, Soddy later went on to call his variations of atoms isotopes, and studied the different ways radioactivity worked in atoms.
This Rutherford has some interesting ideas about the structure of the atom, but his model doesn't account for specifically where the electrons are about the nucleus. I believe that there are rings around the nucleus, and specifically where they orbit contributes to the properties of the atom wherein the electrons are.
Bohr discovered many things for chemistry, including advancing the field of quantum mechanics and for his atomic structure. While his ring theory still works for the simple atoms, it would take the work of our next scientist to truly understand the form of all atoms.
Thus is the likelihood of finding this electron in a certain position. Oh, ich habe es. This is the new atomic model, and ich will call it the quantum mechanical model of the atom.
Schrödinger's complex model of the atom incorporates much of the research of scientists that came before him, using mathematical probabilities to determine the possible locations where electron clouds could be. The quantum model incorporates the fact that particles have properties of both waves and particles. Still, the atomic structure would not be completed without the help of our next scientist.
There are still many unsolved questions about the atom, things that just don't make sense. When I send alpha particles from this radioactive polonium to this beryllium sample, the resulting radiation cannot be explained with only the currently known particles. I propose the existence of a third particle, one without any charge. This neutral particle shall be called a neutron.
With the discovery of the neutron, along with Schrödinger's quantum model of the atom, your modern understanding of the structure and properties of the atom is mostly complete. Of course, chemistry is a constantly evolving science, and many more scientists each contributed and continue to contribute to the atomic theory. Goodbye!